This video is going to focus on solving quadratic equations. But the way we're going to solve quadratic equations is we're going to do it by square roots. And in this video, I'm also going to show you what happens when we get imaginary numbers as well. So the first example that we have will be example 1, and we'll do 2x squared minus 8 equals 16. The reason this one can be solved by square roots nicely is because all you have is an x squared in the problem. And so what you want to do is you want to get the x squared alone. And so when you get the x squared alone, you would add 8. So it's 2x squared equals 24. And then divide both sides by 2. And you'd have x squared equals 12. And now, since the opposite of squaring something is square rooting, the inverse operation of squaring is square rooting, we're going to use square rooting on both sides, and so we'll get x equals, and we have to use a plus or minus when we're solving an equation, and we square root both sides, and the square root of 12 is 2 square root of 3 simplified, and that would be our answer. Alright, now let's do another one, but let's make the solution imaginary. So let's go with negative 3x squared plus 8 equals 29. And so once again, we can solve by square roots. Going to get the square root, or going to get the x squared, this guy, alone. So subtract 8. That'd be negative 3x squared equals 21. Divide by negative 3. And so x squared equals negative 7. And when we square root both sides, notice what's going to happen is we're going to end up square rooting a negative number. And when you square root a negative, it actually becomes an imaginary solution. So x equals plus or minus I square root of 7. How did I get that? Take the square root of negative 7 and break it down. Take 7 times negative 1. The square root of 7 is square root of 7. And the square root of negative 1 is I. So I write it as I square root of 7. There is a few variations to this, especially when we talk about vertex form and what that looks like as a quadratic function. But a couple examples that'll be slightly different, where you have to square root and then keep doing some things, would be like this. 1/3 x minus 2 squared equals 3. See, what we have is we actually have now a quantity being squared. And so what we want to do is we want to get that quantity by itself. So we're going to multiply both sides by 3. And so we'll have x minus 2 squared equals 9. And then you can square root both sides. And when you square root both sides, the nice thing that you'll get is x minus 2 equals plus or minus 3. And so notice x is not alone yet, so what you'll do is you'll add 2 to both sides. But see, what happens is now you have x equals, and you can't make that plus or minus 5, that doesn't work. What you'll do is you'll do 2 plus or minus 3. And so you'll do 2 plus 3, which gives you 5. And you'll do 2 minus 3, which will give you another value of negative 1. And that's how you'll solve problems like that, where you have a quantity squared. So let's look at one more example. Negative 2, let's draw a line down that, x plus 1 squared minus 4 equals 12. And so once again, we want to get the quantity squared by itself. And so you should divide by, oh, just kidding, let's add the 4 first. So you'll have negative 2 x plus 1 squared equals 16, and then divide by negative 2, and so you'll have x plus 1 squared equals negative 8, and we're going to now square root that quantity. Square root, it's square root of a negative, that's okay. So we'll have x plus 1 equals plus or minus, and then the square root of negative 8, we're going to break that down if you want. Square root of 8 times negative 1. The square root of 8 is 2 square root of 2, and the square root of negative 1 is I, and we write that as 2I square root of 2. And now notice the x isn't alone, so I got to subtract 1, subtract 1. They're not like terms, and so x equals negative 1, and then just write plus or minus 2I square root of 2. And that's how you can leave your answer, because you can't combine those. And that's how you would solve quadratic equations by square roots. Alright, see you later.